Hello folks, we are once again back with this exercise 7.6 and it's a problem number 9 that we are supposed to do here now. The problem number 9 is just like the previous problems that we did. So here, but it is now x cos inverse x. Earlier we did tan inverse x and sin inverse x and so on. So let's continue doing it exactly the way that we did the previous problems. As I told you that this is the algebraic function and this is the inverse trigonometric function, and we look at ILATE. So when we look at ILATE, let's allot u and v for these. Because I comes first, inverse comes before the algebraic function. So u has become cos inverse x and v becomes x. Then in that case, we try to find out du over dx, which is minus 1 over root of 1 minus x squared when we take the derivative. And integral of v dx we all know is x squared over 2. Now right away, let's start with the integration, which is by formula integral of u times integral v dx minus du over dx integral v dx and the whole dx. So let's get the value substituted. U for us is cos inverse x and we have got it as x squared over 2. Du over dx we have got it as minus 1 over root of 1 minus x squared, and integral v dx is x squared over 2 for us. Now here we make the necessary changes, like you can take the negative out, you can take the 2 out and all that. So let's take all that and see what happens. Here it is x squared cos inverse x over 2, the first part, and the second part, after you take the negative out and the half out, you have x square over root of 1 minus x squared dx. Now let's see how we can solve this. The x squared that is there in the numerator, it can always be written as x squared. Let me write this, cos inverse of x over 2, the first part, half outside, numerator, that is x squared. We will plan to write it as 1 minus 1 plus x squared maybe to start with, or we could write it as x squared cos inverse x over 2 half times, you could write it as 1 minus x squared dx. The advantage is that you can split this integral. This will become x squared cos inverse x over 2 plus half times integral of 1 over root of 1 minus x squared dx minus half times. These both will come together. It's a root 1 minus x squared over root of 1 minus x squared. So that is just simply 1 minus x squared dx. And we have a ready-made formula for all this, so we can substitute and get the answer. The integral of 1 over root of a squared minus x squared is going to be 1 over a sine inverse of x over a plus c, and root of a squared minus x squared is x over 2 root of a squared minus x squared plus a squared over 2 sine inverse x over a. Yeah, so let's apply these integrals. Here you have x squared cos inverse x over 2 plus half times, we'll apply this 1 over a. 1 over a is 1 itself, so that will be 1 sine inverse of x over a, so that's just sine inverse of x because a is 1. Then we apply the integral here also, half times root of this, that is x over 2 root of 1 minus x squared, then plus a squared over 2, and then sine inverse of x over a. So it's sine inverse of x, a for us is 1, plus c. So thus we have x squared cos inverse x over 2 plus half times sine inverse x, and this is minus 1/4. You know this, when we expand it, it will become minus 1/4. So half minus 1/4 is 1/4. So you will get 1/4 sine inverse x, and the leftover term, it's going to be I hope everything is correct. This is for this, and here whether it is plus, yes, so negative. All right, so this is minus 1 over 4 x times root of 1 minus x squared plus c. This is as of now, but I'll just have a quick checking and see if it's fine. Yeah, perfectly okay. So that's how it is. It's just, though it's a little laborious, but then you just have to put the things properly and get the answer. And this is what the final answer is all about. Yeah, that's all for the 9th problem. With the next problem, let's meet in the next video. Thank you.